Okay, so let us look at the explanation for the um, two-dimensional arrays that you are going to use in assignment 7. So here, let us just start with the very basic things about pointers. So let us say we have an integer variable declared as a equals 5, and that means at some memory address 6000, we are going to say store the value 5, and that's where a is stored. The value of a is stored in address 6000, and say the value of a is 5. So now using ampersand a, you can get that address 6000 where a is stored in memory. So you assign that address value of a to an integer pointer variable. So x is a pointer, and you say it's int start, so it's a pointer to an integer variable. So x itself will be stored somewhere in memory, say at address 8000. We don't need to worry about that address. But what does x stores? X stores the value 6000, which is the address of the variable a to which it is pointing to. Okay, so using x, you can access the value of the variable a. Okay, so if you do something like this, star x equals star x plus 1, then basically x stores the address 6000, and using that it can access this variable at that address, and it can increment that to 6. So if you then say print the value of a, it will print as 6. Okay. Alright, so let us move on to the next level. So now if I want to create an array and access that array through again a pointer variable, I can do something like this: int star x equals say in new int of 8. So I'm creating an array of 8 integers. And as you may know, when you create an array using this new operator, your the integers, like you're creating an array of 8 integers here, need to be allocated in simultaneous memory blocks. So that means if the first integer is created, it's going to be stored at address 600. The second integer of the array should be stored at address 604. The reason why the address is incremented by a value of 4 is because again each is a byte, so integers take 4 bytes in memory. So that's why the first integer, which takes 4 bytes of memory, will be stored at address 600. The second integer will be stored at address 604. The third integer stored at address 608, and so on. Now, so this x is basically now storing the starting address of this array. So we're going to again store x, again stored somewhere in memory. Its value is going to be the 600, and that 600 is basically the starting address of this array. So in your code, if you say you want to access the element at index 5 in the array, you can do x of 5, but how it's accessed is when you say x of 5, basically the starting address 600 is taken from this variable memory where x is stored, plus the index that you want to access, which is 5, times 4. 4 is like, because this x is going to be a pointer to an integer array, it means that the each block will be like 4 bytes. So you multiply that index by 4, you get 620, which is the address of the element at index 5. As you know, the array indexing starts from 0, so this is index 0, 1, 2, 3, 4, 5. So that's where the element at index 5 is stored, and you can access that element right away. Okay, so that's what is happening when you say x of 5 to access an element at index 5 in the array. So now let's get into what is given to you. So actually this is the code given to you in that assignment. You want to create a two-dimensional array basically. So let us say the two-dimensional array has 4 rows and 3 columns. I think I had 5, let me change it to 3. Okay, so So let us look at the first statement, what this statement does. Int star two-dimensional table equals new int star num rows. That's what I'm showing here. So again here assume memory addresses are represented in 4 bytes. That means any pointer is stored in a any pointer it takes up a value which is 4 bytes in memory. Okay. All right. So let us look at this. So int star. So previously we looked at new int here. So that means you're creating an array of 8 integers. Okay. And each cell, each block is going to store an integer value. Whereas here you're creating, let us say num rows is 4, you're creating an array of 4 integer pointers. So each cell is going to store an integer pointer, stores the address of another integer. So each of the cells are going to store some address. Okay, so these are not going to store an integer value. So each of these 4 cells that you're creating are going to store some address. And since addresses are represented in 4 bytes, the next integer, so each value here that you store will be a memory address, and that is, you're assuming memory addresses are represented in 4 bytes. So the next integer pointer will be at address 5004. So assume the starting address is 5000, the next integer pointer will be at 5004, and the next integer pointer will be at 5008, and so on. Excuse me. So this two-dimension table is just going to store that starting address of this array of integer pointers. So this is going to be an array of integer pointers. How many, what is the size of that array? Num rows. So you're going to create, like if num rows is 4, an array of 4 integer pointers. So each of these cells in this array are going to store memory addresses. And the starting address of this array is stored in this two-dimensional table. So now let us go to this code here. We have a for loop that basically goes into, for each row index, you create two-dimensional array of row index. So now you see here, going from what I explained here, when you say two-dimensional array of 0 corresponding to row index 0, so that's going to be at address 5000 plus 0 times 4, that's going to be still 5000. So you're basically accessing this cell over here, and so initially currently it is empty, null, and you are assigning that to an array of, since this is already declared as each block is going to store an address, right? So you can assign that to an array of integer values. So let us say there are 3 columns. So this is like you're creating now an array, like a one-dimensional array like this when you did this here. So you have an array of 3 columns, 3 integers basically, because you're declaring that as integer. And let us say that array starts from address 600. So that starting address of that array is stored in this integer pointer. So this is an array of integer pointers over here. Each can store an address. So this integer pointer stores that address 600, the starting address of this block. Then two-dimensional array of 1 will give you 1 times 4 over here, so that gives you access at 5004. So this integer pointer at address 5004 is going to store, and again the starting address of an array of integers. And how many integers there? Num columns, the number of columns. So say if it is 3, we're going to create an array of 3 integers, and the starting address 700 will be stored over here. Similarly, you can store, and again these are some arbitrary addresses I am coming up with, so they need not be like continuous, like 600, 700, 800 and so on. It could be some arbitrary numbers. Just to illustrate the idea, I am showing these numbers. So then if it starts at 850, the third integer pointer is going to store that address 850, then 950, and so on. So now in your code, if you're accessing, say, the two-dimensional array as it is, a two-dimensional table of, say, 1, 2, what it really means. So you're going to first fetch the pointer address for storing the rows. So you're going to say two-dimensional table is basically at address 5000. It stores the address 5000. So two-dimensional address stores the starting address of this array of integer pointers. You are fetching that, and this is the row index. So, and each element here is going to be like 4 bytes, right? The addresses are incremented in 4 bytes. So 4 times 1, the row index will give you 5004. So you will go to the address 5004 and see what value is there. So the value at that address is 700. So again, that's the memory address storing the starting address of this array of integer pointers. So that 700 will be now fetched, plus again each is an integer pointer that's also incrementing in 4 byte memory units. So that's going to be 4 times 2, and that's going to be 708. So you're basically now accessing the element at address 708, which is this element. So if you think about this as a two-dimensional array of 4 rows and 3 columns, and accessing the element in row 1, which is, again, the indexing starts from 0. So this is row 0, this is row 1, row 2, row 3, and again for columns, indexing starts from 0. So this is column 0, column 1, and column 2. So now you're accessing row 1 and column 2, whatever the value in that particular block, and that's an integer. Okay, so that's how you're accessing a two-dimensional array. Hope this video is helpful to kind of understand the fundamentals behind how to create what's going on behind creating a two-dimensional array using pointers. Okay, stop with this.